believe, like I type strings around my fingers, everything, you know, in order to remember this, and then I forgot. Let me just double check, make sure. Okay, we are recording now. Thank you for reminding me. Oh, so it sends you a message that it's recording. Okay. Well, good. Keep me informed of that. So here's the syntax of a block. Like I said, it's some expressions, one or more expressions, semicolon separated, bracketed by curly braces. Here is the, so we have to introduce a block class. I hope that people have tried this already. So you have to translate this diagram into Scala code. So block extends I see, it's a privacy thing. So block extends special form. Remember, that's just an empty trait. And then a block has, this is the has a arrow, it has a list of, I have 0 or more expressions. This really should be 1 or more expressions, but we won't worry about that. And then block returns the value of the last one. As a reminder, we have this, our environment, our new definition of environment is that it's really a linked list of hash tables, hash maps. Look at the code here. Right, so environment extends hash map. Okay, hash map for us is just a 2-column table. Column 1 are Jedi identifiers, column 2 are associated Jedi values. Ignore this with value for right now. But also, look, it's a recursive definition. So inside, it's got this extension, which is also an environment. So you can chain these things together. And then here I've, the apply is our search function. So we're looking up an identifier in here. And my search function looks inside of this hash map, and if it's not there, it then continues the search by searching the extension. It contains does the same thing. It is an identifier in here, it searches this hash map. If no, it goes ahead and searches the extension. Okay, so just remember that. Okay, and then you have the execute method for a block, and that's where I started drawing these environment diagrams. Let's see. Yeah, I guess it's, maybe I can find one of these environment diagrams, so I don't have to quite get into the artwork just yet. Under demos, maybe. What's its last link? Jedi 1 lab. Environment diagrams. Yeah. So here, for example, is a little bit of a session in Jedi. This is a Jedi session. It defines X to be 10. It returns the notification, okay. And remember what this does is it adds a new row to the global environment. Any definition that's made at the prompt will add something to the global environment. Where's the global environment? Am I breaking up? Anybody else having trouble? Okay. Gee, you're only getting the gist of it. All right. Let me send a text message to the neighbors. the neighbors being my son and daughter. Let's see. Mm. Let's see if that'll help. It's funny. It's like you guys are all in my house right now, so that's cool. So when you make a talk slow, when you make a definition, any definition that's at the prompt, that's going to create an association between X and 10 in this case. I call my name for these associations are bindings. So it creates a binding. X is bound to 10 in the global environment. Global environment, if you check your code for console, that's where it's created. I get this little notification, okay. And then I'm typing in a block. This is Jedi 2. And in the block, I have two, count them, two expressions. First expression is a declaration. The second expression is a block within a block, nested blocks. And so in here, this binding, what's going to happen is every time you execute a block, step one is that you create a temporary extension of the current environment. Remember, execute, you pass an environment in. You pass an environment in, and you're extending that environment with a temporary environment. And this binding y equals 20 is put in that temporary environment. And then the second expression is another block. And so now you're creating a temporary environment, extending the temporary environment. And the z equals 30 is put in there. And then finally, x plus y plus z, that's the value of the inner block because it's the last expression of the inner block. But the value of the inner block is the value of the outer block, since that inner block is the last expression in the outer block. And return 60, which is going to be 30, right, plus 20 plus 10. Okay, just like it would be in Scala or Java for that matter, or C for that matter. Okay, now one thing that's, I hope, going to help you understand how you execute blocks, and something that'll be a feature of the final exam, are block diagrams. So what I want to do here is I want to draw a block diagram. We did this last time. I'm going to draw a block diagram showing what happens just as we are finishing up returning 60 here. And then here is the diagram that I drew for you in class. So these little boxes here, those are hash maps, okay? So this hash map, you see the GE under it. That means that this hash map is the global environment. Remember I said def x equals 10, so here's the binding, x is 10 that got stuffed in that environment. Next, I started executing the outer block. That created a temporary environment. I'm going to call that TE1. It's helpful if you label your drawings too. You're going to be doing exactly this in the final exam, by the way. I'll post some sample problems soon. Drawing these diagrams, and it's very helpful if you label your temporary environment. So TE1 is temporary environment 1, and here's its extension, which I like to label EXT. So that's what we were just looking at in my declaration environment. Here's y equals 20, which got dumped in that environment. And then we started executing the inner block. And so we're re-entering the block.execute. So that creates a temporary environment. I'm going to call it TE2. okay, which extends the current environment, but the current environment was TE1. So this is what I mean by these chain of hash maps. Okay? And in there, it put Z equals 30. And then underneath it, here I'm going to do the computation. So let's see if I can move. So here I'm going to do the little computation. What is X plus Y plus Z? So what is X? So I search here. So my environment apply method would search here for X. No. No panic. Go here, search for X. No. Okay, maybe panic a little bit. Go over here and search for X. Oh, phew, X is 10. Okay, so here's 10. Now what about Y? Search here. No. We go over here. Yeah, Y is 20. Good. Search for Z. Z is 30. So now we can compute 60. Okay, and now we are done executing the inner block. But since TE2 is a local variable inside of execute, this thing now becomes garbage and it's going to get swept up by the garbage collector. So I draw this slash through it saying, okay, that's no longer accessible. But now we're done executing the outer block as well. So TE1, which was local to that execute, is now garbage. Draw a line through it, make a little noise like that. Okay, and now that's done. And now what we see is we're back to the current environment is the global environment. And that's because we're back here, at the top level. So I'll give you a bunch of practice problems for drawing these things. And, I want you to get good at it. And what you're going to do is you're going to have a piece of paper next to you during the final exam. You'll draw this and then you'll hold it up to the camera. You'll take a picture of it or take a picture of it with your phone and you'll upload that to Canvas. More on that later. Okay. Okay, so that's what we covered last time. I think we also talked about the parsers. Just look at that real quickly. So if your Jedi 1 parsers are in good shape, Jedi 2 parsers will be easy. So here, Jedi 2 parsers extends Jedi 1 parsers. So that means you inherit all of those functions. You don't need to redefine them. And then down here is the block parser. And here's the syntax for a block, a little bit more formally. Curly brace followed by an expression, followed by 0 or more expressions preceded by semicolons, followed by a closing curly brace. And so given a string like that, you have to parse it into a block, as we just discussed. Totally easy to do. And then here I'm overriding the inherited term parser, and I'm going to put block in there. I don't know that I guess that's a good place for it. Okay, so parser's easy to do on this assignment. Next, let's look at closures. So closure is our word for a function. Okay, and a function, when you execute a lambda, like lambda x times x, for example, something like that. That lambda, you can think of lambda as like shorthand for make function. So it's a factory method that creates a function. Okay, and what does a function have? Well, a function has a body to it, which is the body of the function. So remember, function syntax is lambda followed by a parameter list followed by a single expression, the body. And it's got a list of parameters, x, y, z. These are the function's internal names for the inputs, right? And those are identifiers. But I gave a demo last time of the static scope rule. Let's just take a quick look at that again. right? Remember this is small guy here, right? So basically here's my is small function. So you're small if your absolute value is less than delta. Delta is defined here in this block. So is small is the body of is, well, the right-hand side of this declaration is a block, which defines a local delta, and then returns this lambda, makes a function. It makes this lambda function, absolute value of x is less than delta. So is small is therefore bound to the function that this guy creates, that this lambda creates. Okay, and remember in the global environment, we also had a delta, a big delta. But when you call is small, right, 99 is not small, negative 99 is not small. It seems to be using this delta, not the delta out here. That's called the static scope rule. You bump into something in the body of a function, when you're executing a function, you bump into the body, bump into something in the body that's not one of the parameters, it's not x, consult the defining environment, don't consult the calling environments. We talked about why that's important, right? So here, when I'm calling is small, it's consulting the environment in which this function was defined. Delta was this tiny number. But that seems to contradict what I just said at the beginning of this class, which was that, you know, when you go into a block, you create this temporary environment. When you leave the block, right, we make that noise, temporary environment's gone, and along with all of its bindings. But that doesn't seem to be happening here. That doesn't seem to be happening here. We seem to be remembering the temporary environment, okay? And that's because, so in order to pull that off, our function needs to remember its defining environment. So the defining environment does not go poof, okay? It does not get garbage collected because this function remembers it. So a function like this that has three parts to it, body, parameters, and an environment, in computer science, we call that a closure. This is an important concept. If you talk about closures during your job interviews, you know, your interviewer will be very impressed if you understand what this stuff means. And that's sort of the essence of functional programming, is that the functions that we create remember their defining environment. They close in around this defining environment, one way to think about it. Also, a closure, of course, so I'll start calling them closure now. So when I say closure from now on out, I just mean a function that remembers its defining environment. And closure is a new kind of value. So this is in the value hierarchy, okay, along with numbers and notifications. What about lambda? Well, a lambda is a new kind of expression. Lambda, remember, is something that you type. Okay, so it's a new kind of expression. Okay, and it has, here's its anatomy. It's got a list of parameters, so that's it. Its parameters is 0 or more identifiers, and it's got a body, which is a single expression. That body could be a block if you have multiple expressions, right? Like our Fahrenheit to centigrade guy. The body had a lot of expressions in it, but they were grouped together as a block, a single expression. And a lambda is a special form. So it is an expression. Okay, so let's see, are we ready? Yeah, I guess we're ready for this. How do I want to do this? Trying to figure out how brave I'm feeling right now, technology. Well, not technology, but teacher technology wise. Yeah, let's do this. I'm going to grab our example that we just looked at for, was it the delta one? So this big. So let me just, yes, I can copy all of this stuff. Okay, so this here is that example I just gave. Okay, and what I'd like to do is I'd like to draw an environment diagram of this. Okay, and to show you what that's going to look like. And say my daughter gave me two things here. I'm wondering, give me this little tiny whiteboard, and let me try this. You know, I should have, this is my fault. You know, I should have been, as soon as this, you know, this virus hit, and I should have tried to I should have thought, oh, you know, how am I going to do, I'm going to do these diagrams online. I should have been perfecting the technology for this. This is coming to you from, this is Pierce's kindergarten class. Let's see, that's going to work. Okay, I think that this is going to maybe work. Okay, so I'm going to draw a picture here of what I'm doing. You might want to put it on speaker view. This is going to be, is that going to be too, is that going to be, this is going to be too small, isn't it? Let's give it a shot. Let's give it a shot, and then you can give me your feedback. So I'm holding this up to the camera. What you can see here is I've got the global environment here. And in here, I've got ABS, absolute value. I'm not going to show you what that looks like just yet. And then I've got delta is 100. And then we put in here is small. I will take a photograph of this and send it out to you. Okay, so next, I'm ready to define is small, but before I define is small, I enter this block and I'm going to create a temporary environment, TE1. And in that temporary environment, that's going to extend the global environment. And in there, I've got another definition of delta, which is this 0.00001. So this is what the picture looks like now. Okay. Now you see TE1, that's because it's just what we were looking at before. We're executing a block. And so we create this temporary environment TE1, and delta is 0.00001 goes into that environment. So we've got two deltas now. Next, we create a lambda. And lambda creates a closure. So I'm going to draw a picture of a closure. Closure is a rectangle with three compartments in it. Okay, the first compartment is the parameter. The second compartment is the body. Already having trouble with. Start over again. I'm drawing this, oh gosh, I'm drawing this on a plastic sheet. This is her teacher's trick. So if I touch anything, it gets erased. And I'll just draw it huge. There's no reason I can't do that. Okay. So here is what's going on now. Okay, so in the bottom of the picture, you see that box with three compartments in it? That's what a closure is. So closure has three fields. The first field is the list of parameters. Our lambda just has one parameter, x. The second compartment is the body, which you probably can't see that well. So that's supposed to say absolute value of x is less than delta in there. Okay, and then the third compartment is the defining environment. Now here's the thing. The environment that this was defined in was TE1, the temporary environment. So the defining environment of this closure is TE1. Now the closure itself, so that box that I just drew, is the value of the block, and so it is what is small is bound to in GE. So is small, like God, I can't read it, so you might not be able to read it either. Is small is, it's bound to, I'm just going to draw, it's like a pointer to that box. Okay, so that's what this looks like. Now, let's see, what do I want to say here? So the definition of garbage in computer science is that there's no chain of pointers that can access it from the global environment. But notice that there is a chain of pointers that goes from GE to TE1 through the defining environment, which I labeled DE. So for that reason, TE1 is not garbage and therefore will not get garbage collected. Okay. Okay. So that's these diagrams get complicated. That's what the environment looks like at this point. Okay. Let's go back to the lecture for a moment. Okay, so what I just described is what happens when you execute a lambda. Okay, that's what we just did. It creates a closure. Okay, the lambda has the body and the parameters come directly from from the lambda. They're inside the lambda. And then, of course, we know this environment here is whatever the environment that was passed into lambda.execute. So it's like one line of code to execute lambda. Just create a new closure. Okay. All right. Probably should have picked an easier example. And I think these diagrams are too complicated for writing on transparencies. Next, fun call. So here is our fun call class that you have for Jedi 1.0. Okay, execute, and I have this ... Okay, and remember how executes, the way execute, I'm hoping that your Jedi 1.0 execute works, is it's got these operands, which is a list of expressions. And so probably what it does is does operands.map execute. Okay, and that will converts, that transforms the operands, which is a list of expressions, into arguments, which is a list of values. And then you pass that list of values together with the operator into the ALU.execute. Okay, and that's sometimes called eager execution because in step one, we execute all of the operands, even if maybe we don't need some of them. Okay, we're eager to know what they are. Contrast that with the implementation I hope you had for conjunction and disjunction. And by the way, I did post some of the solutions in the demos area for Jedi 1. Contrast that with disjunction and conjunction, which execute operands from left to right until you know the answer. And then at that point, you ignore the rest of the operands and just return the answer. But something different has to happen here, right? We have to ask here, so the new algorithm, let's see. So we're going to start out like we did before. We're going to eagerly execute all of the operands. So operands.map execute. Okay, but we have to figure out though, after that, is this operator here, does this operator belong to this environment? Okay, and if it does belong to this environment, is it a closure? So maybe this operator would be something like is small. Okay, so we ask the question, is small a closure that's defined in this environment? I gave you the code for, what's it called? Contains. So environment contains the operator, and is the operator an instance of closure, you could ask. If so, then that's a good test that tells you, this guy is a programmer-defined function. It's not an ALU function. If not, then you just do what you did in Jedi 1.0. You pass the argument and the operator to the ALU, and you're done. Okay? So here, if it is, what you're going to have to do, let's see if I could maybe sketch this out for you. Copy paste the code that we have in here. So step one is args for arguments. Right, so we're going to execute all operands. Right? That's eager execution, we call that. And that's exactly what we did. That's exactly what you should have been doing for Jedi 1.0. Okay, so we eagerly execute all the operands, and then we ask if the operator is programmer defined. We're going to put some code in here. Otherwise, we're going to execute, just do what we did before. So that's the structure of this. Okay, so this is what, first of all, how do you know if it's programmer defined? How do we figure that out? Well, we ask if the environment contains the operator, and the operator should be an instance of the closure class. The value, we'll look up the operator in the environment, and that should be a closure. Okay, so the first step is to create a temporary environment. Just like we do for blocks, we create a temporary environment that extends whatever environment is the current environment, which is passed into execute. Okay? And then what we're going to do is we're going to put it this way, bind parameters. Well, when we look up this operator, right, maybe I should put this something like this. We'll look up the operator in the environment, and that's going to be some kind of a closure. Right? So now you've got your hands on this closure, which means you can, remember the closure has the parameters in it. Okay, so you're going to bind, hang on, no, I'm sorry. I'm telling you the wrong thing. Forget all of this. It's closure. I think it's just this. Don't need to do this. So the operator is programmer defined. You look up what the closure is, and then this is a function. So I just apply the closure to the argument, something like that. Should do the trick. I'll post this code later. Okay. So that's what I'm saying here. So fun call needs to be modified. Okay, now let's go back to closure. So closure is now going to need an apply method. So when you, let's see, what am I sharing the right thing? No, I'm not sharing. I'm still sharing this. What am I sharing? I'm sharing this, right? So here, remember that this is code for in Scala. When it sees, it looks like you're calling a function here, closure is actually an object with an apply method. And so this parses into this in Scala. Okay, so back here to this, I have to redefine apply for closure. Okay, so what's that going to look like? What does closure have? It's got parameters, it's got a body, and it's got a defining environment. It extends value. It's got apply method. And this apply method takes as its input a bunch of args, which is a list of values, just like in the ALU. Okay. Step one, we create we're going to create a new environment, temporary environment, which is extending, and here's the big trick right here. It doesn't extend the calling environment. It extends the defining environment, which the closure remembered. Remember, this def env was the environment that was around at the time we executed lambda. Okay, so it's going to create this temporary environment, which extends the defining environment. We're going to, I'll say bulk. This is very sketchy. If you look at my definition of environment, I've got a bulk put method in there. And with each of the parameters, well, here are the parameters right here, a list of identifiers. We're going to associate them to arguments. Here are the arguments right here. It's a list of values in the temporary environment. And then finally, we'll execute the body. Here's the body right here relative to this temporary environment. Okay. So again, fun call, let's walk through this. Fun call, we're executing a fun call. This might be, for example, is small 99, okay? So we eagerly execute the operands, just like we did in Jedi 1. Bigger. Next, we say, oh, well, if the operator is a programmer-defined closure, then let's get that closure. You can just execute env of operator, just search the environment for the operator, or you could also do, it might be safer to do execute the operator. It's an identifier. An identifier is a kind of expression. And that should return a closure. And then we apply the closure to the arguments. Otherwise, we just pass all of this stuff to the ALU. If it's not programmer defined, maybe it's built in. Or, maybe the programmer has lost his mind and it's, it's nothing. So here we are in apply. We're going to create a temporary environment extending the defining environment. So the environment that was around when the closure was created by a lambda. We create a temporary environment extending the defining environment. We put the parameters associated with the arguments, using that bulk put, and then we just execute the body in the temporary environment. So it will literally probably be about 3 lines of code. Okay. Let's do a simple example, and we'll come back to, see, what am I doing? So let's do a simple example. We'll do a simple example. Here's, oops, I'm forgetting what language I'm in. That was a Scala declaration. Okay, so let's do this example. I'm defining square, which is this lambda, okay, and that's going to create the closure. And then here's a fun call. I'm calling square of 2 times 3. So let's see technology. Let me try the whiteboard technology. See if that works any better. Let's see, I'm going to change the name of this to just SQ so I don't have to write so much. Now, this is going to be visible here. So what I've got is the global environment. Okay, and in the global environment, I've got SQ, and SQ has got a pointer going to that closure object. That's the thing with three compartments. The parameter for the closure is X. The body, it's hard to read, is X times X. And the defining environment is the global environment in that case. So DE is equal to GE. Okay. So again, when you execute a lambda, you create one of those closures. That's going to be lambda.execute, create a closure. Parameters are, well, it's right there in the lambda, X. The body is right there in the lambda, it's X times X. And the defining environment is whatever the environment was when you were executing the lambda. It was passed into lambda's execute function. In this case, since all of this was defined at the prompt, the only environment around is the global environment. Next, I'm going to call SQ of 2 times 3. So that's a fun call. So we're inside of fun call.execute now. So there is one operand, 2 times 3. If you execute that operand, you get the argument 6. So there's only one argument. It's a list containing one value, the value 6. Next, I'm going to ask, is SQ in the global environment? Is it defined in the environment, the current environment, it's a global environment? And if so, is its value a closure? And here we see that, well, yes, SQ is in the global environment, and its associated value is a closure. Okay, so we grab that closure. So we're grabbing the triple compartment box. Okay, and we're applying that closure to 6, the argument, the list consisting of one argument. Okay, so we're now going to follow this algorithm. I'm going to create a temporary environment. The temporary environment extends the defining environment. And then I'm going to bulk put the parameters, there's only one parameter, x, with the arguments, there's only one argument, 6. And then I'm going to execute x times x in this environment. To get 36. So now here's what things look like. I'll try to do a nice version of this. So look down here. So you see I've created TE1. So that is that number 1 enclosure apply up at the top of the screen. It create a temporary environment. Step 2, put the associate parameters with arguments. Well, I know the closure's parameters right there in front of me. It's just a list of one identifier, x. So, and I know what the arguments are because those are the inputs to apply, which is just a list consisting of 6. So it's x equals 6. And then finally, I'm ready for step 3, which you see just to the side of TE1. Let's execute the body relative to this temporary environment. So x times x is 6 times 6 is equal to 36. And now we're done executing the closure, which means we get to make our whoosh sound. The temporary environment is garbage now. It's no longer valid, and the current environment goes back to being the global environment. Okay. All right. So how am I doing here? I'm doing okay. So I guess what I'll do, maybe I'll try to do nicer pictures of these and post them so you can study them. Okay. So all of those environment diagrams, those are getting created during runtime, during execution time. Let's go back now. Not feeling particularly brave about this. Let's go back to is small. Remember, this was the is small picture. And is small, the defining environment of the closure is not the global environment, it's TE1. And so now I'm going to call is small of 99. Let's see. let's see, the parameter is X, and the argument is 99. So this, there. So now this is what my environment looks like. Okay, so what happened here? Well, we are now calling the fun call is small of 99. So step one, we eagerly execute our operands. We have one operand, 99. It's a literal, so its value is itself 99. So it's also the argument. Okay. And next we ask, well, is small a user-defined function? Look in the global environment, that's the current environment, right? And why, yes, it is. And then we look up that closure and we apply it to 99. So now we're in closure.execute, so we're over here. Okay, we create a temporary environment. This is TE2. This temporary environment extends the defining environment of the closure, right? So here, the temporary environment does not extend the global environment, which is the calling environment. It extends the defining environment, TE1. I put TE1 in quotes there because it's not really temporary, is it? Okay, so that's TE2. And next I associate in TE2 the parameter X with the argument 99. And then I'm going to execute, I'm now ready to execute the body, which is the absolute value of X is less than delta. So the absolute value of X is 99. So now, here, I don't know if you can see that, but I'm doing my computation under TE2. I'm asking, is 99 less than delta? Is 99 less than delta? Well, where's delta? It's not defined in TE2. So what do? Well, I look in its extension. The extension does have delta, and it's this teeny tiny number. Okay, and so yes, 99 is less than that. So it's not less than that. So I'm going to return false. Okay, and now TE2 gets whisked away. Okay, not TE1 though, because there's still a chain of pointers going from the global environment to it. If this had been, and that's really the static scope rule in action. When you're looking for something that isn't a parameter in the body of a function, search the defining environment. In this example, the calling environment was the global environment. And if you look at the screen, right, I mean, that's, that's the, is small as being called at the prompt. In the dynamic scope rule, the discredited dynamic scope rule, we search the calling environment, and there we would have gotten delta is 100, and 99 is less than 100, so it would have returned true. 99 is small, and that would, of course, pissed off all of our customers. Okay. So, I think so you should know, like, this apply and closure is like 3 lines of code. You have to redo lambda execute is 1 line of code. And then this modification of fun call is just like what I showed you. I'll post those sketch that I did. And then finally, there's the parser. Come back to the parsers now. So here is my lambda rule. The format of lambda is it's the string lambda followed by parameters, followed by, this is the body, the expression. Parameters is a separate category. Okay, so this is a left paren followed by, all of this is optional. See the question mark? An identifier followed by, and then this part is going to be repeated 0 or more times, more identifiers preceded by commas. And then finally, this part is required, a closing right parentheses. Okay, params, the params parser will return, what does it return? It's going to return a list of identifiers. A list of identifiers, not an expression, but a list of identifiers. Okay, so that's exactly what we need. Remember, this guy is going to create a a lambda expression is what this generates. And the lambda expression is going to be that's my cat. Lambda expression is a special form. It's got a list of parameters and it's got the body, just exactly what you want. So it's super easy to do. And then I think I've given you some test code here that you can test it out with. So this is like just a file of things. You can see some of the functions that I'm defining here. Okay. Okay. So I think that's plenty for today. I'll try to get better versions of these diagrams posted. Questions, let's see what you've got here. Can we see your cat? I've got 2 cats here. This is Miles. He's going to run away. He's the dumber of my 2 cats. Say hello to the college student's cat. And then I've got a gray cat named Nala, and she's the smarter of the cats, but she's smaller than Miles, so. Okay, looks like my cat Spot is your cat. By the way, none I should like a disclaimer here. Technically, I don't own either of these cats. I'm like one of those people who inherits cats, people who buy cats and then or get cats and then say, oh, I guess I couldn't take care of these cats. And so they dump them on me. So these cats are technically not mine, but they're my cats. Okay, so I guess I'll see all of you on Thursday. Thanks for, thanks for suffering through this. And I will see you guys on Thursday. Bye.